Hey class, we are taking notes on our new unit, section 1.5. Topic is called transforming graphs. Today's date is the 21st. Our essential question is, how do we transform graphs? And we have seen this concept before in Algebra 3-4. And so this should be definitely a review as we're doing this. So things should sound really familiar. And so that's the reason why I will be probably going really quickly, pretty straightforward, and not going into details. So let's go ahead and start. And so we have different kinds of shifts and factors that could cause the graph or the function to transform. So we're going to do vertical shifts, and vertical shifts are like up and down. We're going to focus on several different types of graphs as we're doing this. And the graph that we're going to work with for this one is a parabola. So I always do 1, 1, and then 2, 4. 2, 1, 2, 3, 4. 2, 4. Here's my parabola. This is, I'm just use y. We've been using f of x, so I think for this examples, y works really well, and so I'll use y. That's x and that's y. So how do we make this graph shift up? And does it sound really familiar? If we add anything to x squared, like plus 2, plus 4, plus 5, it's going to make it go up, right? Because whatever value we get here, if we add 1, 2, or 3, it'll move it up. So we'll move up 1, and these points will also move up 1. So we have 1, 1, 1, 1, and I don't have enough to do the next point, so I'll just do this for now. This is y equals x squared plus 1. So I made it move up 1. Let's zoom in on that, because we don't need this right side right now. Alright. And in my notes I wanted to do plus 2, but I wasn't paying attention to my notes, so maybe this one down here. So x squared plus 1 made it move up 1. What if I did minus 2, right? What if I did y equals x minus 2? So that means that I'll move the graph down 2. So 1, 2. This is still 1, 1, 1, 1. And let's do the 2, 4. 2, 1, 2, 3, 4. 2, 1, 2, 3, 4. So this function is the function y equals x squared minus 2. And I kind of choose a lighter blue here. I forgot I was going to grab a different color pencil, so that is darker, but hopefully we can see this. This is y equals x squared plus a minus 2. So let's take a look. What caused it to shift up? So our function, this is a general function, y equals x f of x, right? That's just any function. Y equals f of x is just any function. What made it move up? If I add anything to the function, so if I add a k to it, it'll cause it to move up. So this caused the function to shift up. So if I add any k to the function f of x plus k, x plus k, x squared plus k, the absolute value of x plus k, it'll move it up. What makes the function shift down? Minus k will make it shift down. So these are the vertical shifts. Plus k makes it move up. Minus k makes it move down. And that should sound really familiar to what we did maybe last year in Algebra 3-4. And we cannot see this, Mr. Cha. Come on. All right, there you go. I apologize. I was not paying attention to what we can see there. All right, let's continue. So that's vertical shifts. Let's do horizontal shift. What makes it move left and right? And for this function, let's kind of change the function up. I'm going to change them every time just so we're seeing a variety of functions, right? A variety of functions. All right, so this function here is the square root function. If I plug 1 in, square root of 1 is not 1, so let's do the square root of 4. The square root of 4, it will give us a nice number. So 1, 2, 3, 4, 1, 2. So square root of 4 will give us 2. So here is the square root function. I'm just choosing nice numbers to help us out. So square root of 4 gives us 2. All right. So how do we make this function shift to the right? Let's say it moved 2 to the right. And 1, 2, 3, 4, 1, 2. So somewhere over here. I really did not want it to be that close to what I wrote there. So this is y equals, what makes it shift to the right? If I do x minus 2. So the square root of x minus 2. And notice that it's inside and not outside. For example, if I wanted to shift up, it would have been the square root of x, close the square root, plus k on the outside. This is minus 2 on the inside. So minus 2 is to the right. Okay? How do we make it move to the left? So let's move it to the left 2 times, or 2 spaces. And 1, 2, 3, 4. So we are right here. Oh, I'm sorry, up here. 4, 2. So there we go. This is y equals the square root of x plus 2. And I'm actually going to write this over because this blue pencil is not showing it very clearly. And I apologize for that. There you go. So plus 2. So let's write that down. What makes it move to the right? If we change anything inside with the x, so x minus h makes it move to the right. So this shifts right. Y equals f of x minus h. And the minus h is in the inside with the x. Same thing with the right side, f of x plus h shifts to the left. Okay, and usually this confuses a lot of students because sometimes when we think about subtraction, right, we always think about it going down. And so when we see the minus here, we think that it moves to the left because sometimes left is in the negative, right, in the negative side, and the plus means the right side. But the reason why is that is because h is positive. H is positive in this form here. So if h is positive, it would be x